Good morning, students. This is the third review for benchmark 3. In this video, I will discuss the problems numbered from 15 to 34. Before that, let me review the end behavior of these functions. Suppose if you have a function f of x equals x square, then you'll get a parabola curve like this. It means your leading coefficient is positive leading coefficient, and your exponent is even number. Okay, this is leading coefficient, exponent is even number, then both ends will go up. But in a mathematical way, if you want to define this one, so as x tends to infinity means your x is going from 0 to infinity in right direction. Your function x, f of x, is going upward direction. So your f of x is tending to infinity. In the same way, as x tends to negative infinity, your f of x, so in this direction, when you move in this direction, your curve is also going up, right? From here, this curve goes up. So f of x is also tending to infinity. Or if you want to combine these two, the combination of these two results, I can write it as x tends to plus or minus infinity, your f of x is tending to positive infinity. Okay. Next, coming to this second graph, you can observe it is complete opposite to f of x equals x square. So here both ends will go down. So how do you write this one? It is negative leading coefficient with even exponent. So again here you can observe here, as if you move in this direction towards right, your curve is coming down, right? So as x tends to infinity, your f of x tends to negative infinity, right? It is coming down. So if you move in the opposite direction, that is in this way towards left, that is as x tends to negative infinity, what is happening here? The curve is coming down. It means it is going towards negative infinity. So your f of x tends to negative infinity. Again here, if I want to combine these two results, I can say that as x tends to plus or minus infinity, f of x tends to negative infinity. This arrow mark, always we read it as tends. Tends means approaching. Means if x is approaching to positive infinity or negative infinity, then your f of x approaches to negative infinity. Okay, here itself I will give you some more examples. What happens if you have the exponent is more than 2, means if the exponent is x to the 4th power or x to the 6th power and so on, then what happens, now here I am drawing the graph here. So the graph becomes more flatter at 0. So it goes in this way. Now observe the difference between x square and x4. This is x4. So your x to the exponent 6 becomes, still it is more flatter at 0, like this. Okay. So this is x to the 6th power. Now in the same way, if the leading coefficient is negative and if you have the exponent is x to the 4th, negative x to the 4th, then you will have a curve passing through origin, but the thing is it is flat at x4. If it is negative x to the 6th power, then it is still more flatter. It goes like this. Okay. So this is the properties for leading coefficient positive even exponent, leading coefficient negative even exponent. Right. Here the curve is f of x equals x cube. So your positive leading coefficient, so it is positive leading coefficient and exponent is odd. Then left side it comes down, right side it goes up. Remember this one. Again, in a mathematical way we can define this one as x tends to infinity, means your x is moving in this direction, then your f of x is going up, right, in this way. So f of x tends to infinity. Now let me use the different color here. Now as x tends to minus infinity, means you are going towards left now. When you are taking x is tending to minus infinity, then your curve is coming down. It goes towards minus infinity. So f of x tends to minus infinity. So right, you cannot combine here these two because they are entirely different one. In the same way, now when f of x is negative x cube, your curve looks like this. It means when you go from 0 to infinity, if you move in this direction, right side, that is as x tends to positive infinity, then your curve is coming down, right? So your f of x is tending to negative infinity. Okay. In the same way, suppose if you are moving towards left in this direction, then your curve is going up. It means as x tends to minus infinity, then f of x tends to positive infinity. So again here you cannot combine these two results. Right. The important thing I want to explain here is, suppose if you have f of x equals x to the 5th power. So what happens here? So the curve goes through 0, but it is flat at 0. So it goes like this. Right? Suppose if you have f of x equals x to the 7th power. So again here it moves from left to right, but more flat at 0. Okay? In the same way, if you have f of x equals negative x to the 5th power, then your curve will be going from left to right, but it is flat at 0 and goes down. Okay, it means more flat here. Remember this one, more flat here. So, and when the x power goes on increasing in these cases, it is more flat, but it goes up on the left side and goes bottom to the right side. Okay, here the curve looks like this, right? So left side it goes up, right side it comes down. Okay, right. Now this is one example I took how to write the polynomial from the graph. Okay, here the curve is passing through A, B, C, D, E and F, right? So it passes through A, B, C, D, E, F. But okay, you can see at A it goes through, right? At A it is going through. But at B it is bouncing back. So when it goes through, we write the factor as x minus a if it is goes through. Right? And even it is going through C also. So it is x minus C. Right? And x minus E. So the curve is going through all these 3 points A, C, E. But it is bouncing back, it is bounces back at B, right? When it bounces back, we write it as x minus b to the 2nd power, right? Bounces back at B. And even it bounces back at D also, right? But you see at D it is more flatter. At D, the curve is more flat. So we take more flat and bounces back. So bounces back, more flat means what I told you? We should take the exponent is more than 2. That is, I can take x minus d to the exponent 4. Alright? Next. At E, the curve is at E, the curve is flatter and it goes through. The curve is flat and going through. So the curve is flat and going through. We write it as x minus e to the exponent 5. Alright, and at f it goes through. So this point comes over here, that is x minus f. So now we multiply all these factors to get our polynomial. So that is x minus a, x minus c, x minus e, x minus f, and x minus b to the exponent 2 to the second power, x minus d to the fourth power, and x minus e to the fifth power. Okay, but here why x minus e is repeated twice here? So it is going through, but it is more flat, so I can take it out this one. Take out this one. A. So this is your final expression. X minus a, x minus c, right? X minus f, x minus b to the exponent 2. So what is your leading coefficient and the exponent? How many x's we have? So the exponent is 1 here, 1 here, 1. So 5 plus 4, 9, 9 plus 2, 11, 12, 13, 14. So positive leading coefficient to the exponent 14. So then what happens? Both ends goes up. See here? So the both ends are going upwards direction, right? So this is the way how you are going to find out the polynomial from the given graph. Yeah, problem number 15. Now if you observe this graph, left side it is going up, right side it comes down, right? Okay, it means here the leading coefficient should be negative, leading coefficient should be negative, and the exponent should be r. Right. So what is this point? This is 2, that is negative 2, and this is 0, and this is 3. So now you observe here it is going through, it is not bouncing back or it is not flat at any point. So straight away what I can write here? So the leading coefficient should be negative. So this point I can write it as what? X plus 2 is a factor form. We have to flip the factor. This is x and this is x minus 3. So multiply all together, it is x plus negative x plus 2 times x minus 3. So which is the right option here? Negative x times x plus 2 and x plus 3. C. Yeah, in problem number 16, both ends are going up. So both ends goes up. It means positive leading coefficient with even exponent. So this point is negative 5, right? This here it is, see, it is flat and it is going through minus 2, and it is here it is, this is 1. So when it is going through, I can write this point as this factor form is x plus 5, and it is more flat and going through, more flat and going through. So this will be x plus 2 to the exponent 3, right? And here it is bouncing back at 1. So this one I can write it as x minus 1 to the second power. So combining together, it is x plus 5 and x plus 2 to the third power and x minus 1 to the second power. So the option is first option. You can verify the result here. So how many x's we have here? 2 x's, 3 x's and 1 x. So how many x's we have? 6 x's, means positive x to the 6th power. So this, which is nothing but positive leading coefficient, and exponent is even. Yeah, in this problem number 17, the end behavior is given in mathematical form, right? So as x tends to infinity, x tends to positive or negative infinity, your p of x is tending to positive infinity. It means the curve looks like this, right? But we do not know whether it is fourth degree or second degree or sixth degree and so on. Okay, but you see the number of roots here, means both ends will go up. We know that it should be positive leading coefficient to the even exponent. Okay, it means I can rule out this option A and option C. So either option B or D. So what we do here is the roots are given to you as 2i and 3 here, right? So what we do is we check the solution x equals 3, whether x equals 3 is a solution for B, the given polynomial. So what are the coefficients you have? Use synthetic division here. 1, negative 4, 7, negative 16, positive 12. So what I am doing here is I am finding out whether x equals 3 is a root for this polynomial or not. So bring down this 1. So that is 3, negative 4 plus 3, that is negative 1, negative 3, 7 minus 3, that is 4, 4 times 3, 12, negative 16 plus 12, negative 4, so negative 4 times 3, negative 12. So we got that x equals 3 is a root for the polynomial, second polynomial, right? So the option B is the right one. Even we need not check for the option D. Yeah. In problem number 18, which of the following polynomial functions has 5i and minus 2 as two of its roots and has different end behaviors? Different end behaviors means either it goes up or down, or comes down or goes up. But in the given four options, so if it is different means I can rule out this A and C because it is even degree polynomial, fourth degree polynomial, right? So that's why straight away I can eliminate the answer A and answer C. So among the options B and D, one has to be right. So again here check whether x equals negative 2 is a root for the polynomial B or D. So first let me write the coefficients here. 1, negative 2, 25 and negative 50. So x equals negative 2 here, right? So bring down this one. 1, negative 2, that is negative 4, 8, 25 plus 8, 33, 33 times negative 2, negative 66. Okay. This is negative 116. So x equals negative 2 is not a solution. So B is also ruled off. So the answer is D. Yeah. In problem number 19, what are the x-intercepts and y-intercepts of the following function? So if you want to find out x-intercept, then you plug in y equals 0, right? So what if you plug in y equals 0, what you get here? Means each factor we have to equal them to 0. So x minus 1 equals 0, you get x equals 1, x plus 2 equals 0, so then you get x equals negative 2, x minus 3 equals 0, you get x equals positive 3, x plus 4 equals 0, then you get x equals negative 4. So the roots are, x-intercepts are negative 4, 0, this one. Next point I can take negative 2, 0. Next point I can take it as 1, 0 and 3, 0. Right? Now, if you want to get y-intercept, then we have to plug in x equals 0. So your y equals f of x equals negative of 0 minus 1, right? 0 plus 2, 0 minus 3 and 0 plus 4, which equals negative. So it is 4 times 3, negative 12, negative 12 times 2, negative 24, negative 24 times negative, and we have three negatives, so it is negative 24. Is it right? Please check it out. So this is negative, let me go through again, negative of negative 1 times 2 times negative 3 times positive 4. So how many negatives we have? 1, 2, 3. So it is negative. So the answer is 0 comma negative 24. So which option is right? Option B. Right. Option B is right. Yeah, problem number 20. If the end behavior of the polynomial of the function is given here in a mathematical form, then what must be true regarding the leading coefficient? Okay, only leading coefficient, right? So we separate these two statements first. So as x tends to infinity, your first statement is f of x tends to what? Negative infinity. So let me draw a line here. So change the color. So when x is going in this direction, your f of x is going to negative. So in this way, right? Okay. Now, what is the second statement? As x tends to negative infinity, f of x is tending to positive infinity. So let me change the color again. So when you are going towards left in this direction, your function is going upwards, right, in this way. So this is negative infinity and this one is positive infinity. So what does this mean? Leading coefficient should be negative leading coefficient, and the exponent should be odd. But ask me to find out what? Only the leading coefficient. So the answer here is the leading coefficient must be negative. Right, problem number 21. Which of the following statements is true for the given polynomial? So first let us find out the leading coefficient here. How many x's we have? 2 x's, 2, and here it is 1, here it is 1, right? So it is x square, x cube, x to the fourth. So you have leading coefficient is negative 2x to the fourth power. So negative leading coefficient, and the exponent is even, then both ends will come down, right? So how do you express this one in a mathematical way? So draw your lines. So first you move towards what? Right. As x tends to infinity, as x is tending to infinity, both should come down, right? So your f of x goes to minus infinity. Okay. Next, when you move towards left in this direction, as x tends to minus infinity, you goes down in this way. So f of x tends to minus infinity. So look for these two options where it is. See, you see the first option as x tends to infinity. No. F of, as x tends to infinity, f of x is tending to minus infinity. Second option is right. As x tends to infinity, f of x tends to infinity. This is wrong. So this is right. So option second and fourth is right. So answer is D. Yeah, in problem number 22, which statement is true regarding the function? Right. So first, let us find out the degree and the leading coefficient. So the degree is x to the third power 3, 2, and here you have 1, right? So negative x to the power 3 plus 2 plus 1, negative x to the sixth power. So negative leading coefficient and even exponent. It means both ends will come down. Right. Okay, that is one property we know. Now, the end behavior is not same at both ends, but it is same here. So the option 1 is wrong. So the function is positive when x is between negative 1 and 2. Okay, let me check this one. So if you plug in x equals 0, what do you get? So negative of 0 plus 3, 0 plus 1 square, and 0 minus 2's cube. So it is negative 3 times 1 square means 1, negative 2 cube is negative 8. So you get this value as how much? Negative, that is positive 24. Okay. Now let us decide the function is positive at between negative 1 and 2. Take any one value between those two and check it out. Okay. Okay. Now let me check with option C. The function is a relative maximum at negative 1, 0. So first of all, let us draw the graph for this one. So it is negative 3 here, negative 1 and positive 2. We know that both ends should go down. So the first one is only x plus 3, so it passes through. And next you have square, so it is flat at negative 1. And the next one is cube, so it goes up from here and flat at 2 and comes down. So the function has a relative maximum at negative 1, 0. Maybe this option is also right, but y-intercept is 0, 24. Y-intercept means we should plug in x equals 0. When you plug in x equals 0, you get 0, 24 here, right? That is what we got here when you plug in x equals 0. So the three options, you got it as right. Okay, one more thing I want to say here, that is you will be getting maximum here, right? And the minimum here. But we are getting a minimum at a negative 1. So this is should not be maximum, it should be minimum. So this option is also rolled out. Okay, so option B and option D are right here. Okay, problem number 23. If x is an integer, which statement below must be true? So to find out which option is right, x is an integer, it says, right? So for any integer, this statement must be true. Let us try with x equals 1. So what is this first option? So when you plug in x equals 1, you get 1, 1 plus 2, that is 3, 1 plus 4, 5. But what it says here? The consecutive even integers. So option A is wrong. Now look for the second option now. X equals 1, right? You get 1, 2 and 3. These are not three consecutive odd integers. So option B is wrong. Option C. Plug in again x equals 1 here. 2, 3 and 2 times 1, right? 2 plus 3, 5. The product of consecutive 3 odd integers. But these 3, we got 2, 3, 5. So that is wrong. When you plug in x equals 1 here, what happens? 2 plus 1, that is 3. 2 times 2 plus 3, that is 5. 2 plus 7, 5, that is 7. So 3, 5, 7 are consecutive odd integers. So answer is D. So problem number 24. The polynomial expression represents the volume of the shaped box shaped as a rectangular prism. So rectangular prism volume is length times breadth times height. Okay, now this one, what he has given you here, 2x cube minus 3x square minus 5x plus 6, which is equal to x minus 1, 2x plus 3 and x minus 2. Okay, now this represents what? Length, breadth and height. So those are the dimensions of the box. Option A is right here. Okay, construct a response. Graph the function when a polynomial is given if a, b, c are positive integers. A is less than, b is less than c. Means a comes first, b second, c third. So before that, let us find out the leading coefficient and exponent. So here we have 1 as the exponent, right? So 2 plus 3, 5, 5 plus 1, 6. So the leading coefficient is negative and we have even exponent. Leading coefficient is negative and even exponent. So both ends will go down. Okay. Now ask me to draw the graph for this one, right? Okay. So what are the factors here? X plus a is a factor, right? So what is x then? X equals negative a. Next one is x equals positive b. And the third one is x equals positive c. So this is negative a, for example. This is negative a, positive b, and positive c. So both ends should go down. Here it should go down. Here also it should go down. Right. Now the exponent is 2 here, right? The first exponent is 2. Means at negative a, it bounces back. Right. It bounces back. But at x equals b, it is flat and goes through. Okay, it's flat and goes through. And at x equals c, it is going through. So it comes down and goes through. Yeah, that's your answer. Select the expression equivalent to. So this is 3x to the exponent 2 over 5. So it is 3 times, okay, x to the exponent 2 over 5. Remember how we are going to do this one. This 5, you are going to bring it, that is 5th root of x square. So that's your answer. So the option is C. Problem number 27. Which of the following is equivalent to the expression x to the exponent 1 over 3 times x to the exponent 1 half? So when the bases are same, we add the exponents. So that is 1 over 3 plus 1 over 2. Recall how we are going to add when the denominators are different. We multiply these two, that is multiply the denominators, next cross multiply 1 times 2, that is 2, plus 3 times 1, that is 3. So which is x to the exponent 5 over 6. So again we bring down this one, that is 6th root of x to the exponent 5. So the answer is C. Yeah, problem number 28. We have 5th root of x cube times 4th root of x. So we write this one as what? We bring down this one as the denominator over here. So x to the exponent 3 over 5 times x to the exponent 1 over 4. So when we have same base, we add the exponents. So x to the exponent 3 over 5 plus 1 over 4. Okay, now let us simplify this one. So again we have different bases here, so different denominators. So multiply the denominators, cross multiply it. 3 times 4, that is 12. 5 times 1, that is 5. So which equals x to the exponent 17 over 40. So again we'll bring down this one as the radical, that is 48th root of x to the exponent 17. So which option is right here? I'm sorry, this is 5 times 4 is 20 here. So let me erase this part. So that is 17 over 20. So 20 goes over here. So the option A is right. Right. Here the problem number 29 is fifth root of 38,880 x to the 12th power and y to the 9th power. Right. So first let us pull out our calculator and go to second and math. No, I'm sorry. Okay, before we proceed to this problem, let us find the factors for 38,880 whose fifth power whose fifth power should be equal to this, right? Okay, let us pull out the calculator first. Now the first option says that you have 5 here, right? So what is 5 to the exponent 5? So 3125. But here we have 38,880. So the option A is wrong. Now let us check with the second option. Second option says that if you bring this one inside, it is 6 to the 5th power. Alright. So what is 6 to the 5th power? 6 to the 5th power equals 7776, that multiplied by 5, right? Multiplied by 5, which gives you 38,880. So we can write this one as 6 to the 5th power times 5. So I will write over here. So 6 to the 5th power times 5 times x to the 12th power and y to the 9th power, and everything is fifth root of this one, right? So which equals, bring this 5 to every part of the denominator here. So 6 to the 5th power divided by 5. So what we get here? So you bring down this one over here, bring it over here, and bring it over here on the denominator. So this is 5 to the exponent 1 over 5. This is x to the exponent 12 over 5 and y to the exponent 9 over 5. So 5 over 5 means that is 6. And what else you can bring it out? This one I can write it as x to the square, because 12 divided by 5. 12 divided by 5 I can write as 2 over 5, right? So 2 and 2 over 5. And in the same way, 9 over 5, what you can write? 5 times 1, 5, 4 over 5. So this is y, and y times 1 over 5. So wherever you have the denominator 5, you keep all that one in the parentheses. This one you have, right? 5, denominator 5 here, and denominator 5 here. So the remaining everything you can write this one as after 6, so I'm bringing down this one, this 6 x square, this is x square I'm bringing here, and what else, y, you have here x to the exponent 2 over 5 and y to the exponent 1 over 5. So this answer is 6x square y. This both 5's you bring it out. So fifth root of x square y. So that will be your answer. So option B is right. Okay, let me simplify this one. So which exponent is more, 4 over 7 or 2 over 7? 4 over 7, right? So this one I can write as m to the exponent 4 over 7 minus 2 over 7. So whichever the exponent is more, that variable stays there. Similarly here 1 over 5 and 4 over 5. I can write this one as that is 4 over 5 minus 1 over 5, which equals m to the exponent. So 4 minus 2, that is 2 over 7, divided by 4 minus 1, that is 3 over 5. Now see where you will get this answer. So the first option is ruled out, second option is also ruled out. Now we need to simplify this one, right? So option C is what? M to the exponent 2 over 7, n to the exponent 3 over 5, divided by m and n. So which number is more, 2 over 7 or 1? 1 is more, right? So this way m stays in the denominator, so n also stays in the denominator. So we can write it as 1 over m to the exponent 1 minus 2 over 7, n to the exponent 1 minus 3 over 5. Okay, this is 7 minus 2, that is 1 over m to the exponent 5 over 7, n to the exponent 2 over 5. So which is not equal to this. So C is also wrong. So definitely D is the right answer. So problem number 31 gave you two equations here. M to the exponent n equals 512 and 4n equals 3. So first let me find out n here, divide by 4. So n equals 3 over 4. So substitute this value in the place of m. That is m to the exponent 3 over 4 equals 512. Now find out whose fourth power is 512. So 8 to the exponent 4 is 512. You can check it out. 8 times 8 times 8 times 8, which gives you 512. So what I am doing here is I am writing 512 as 8 to the exponent 4. Okay, now m to the exponent 3 over 4, I am raising this one to the exponent 4 here, and 8 to the exponent 4 raised to the exponent 4, right? I am raising both exponents to 4. So what I must now? This is m to the exponent 12 over 4 equals 8 to the exponent 16. So this is m cube equals 8 to the exponent 16. Okay, now how can we simplify this one? So m equals cube root of 8 to the exponent 16. Okay, now we need to bring this 3 to the denominator over here, which is 8 to the exponent 16 divided by 3. But 16 divided by 3, I can write it as 5 1 over 3. So that is 8 to the exponent 5 and 8 to the exponent 1 over 3. So let me find out what is 8 to the exponent 5. 8 to the exponent 5, which gives me 3 to the 32768. 32768, and this is cube root of 8, that is 2. So which is times 2, which gives me 65536. 65536. Yeah, I did a mistake here. It is not 8 to the 4th power, it is 8 to the 3rd power, right? I'm sorry here. So we need to change everything. So this is 8 to the 3rd power. Okay, this is 8 to the 3rd power. So raising both sides to the 4th power. So this is 8 to the 12th power, right? So 8 to the 12th power. This one I can write it as 8 to the 12th power. What I can write? So I want to simplify this one so that I can get only cube here. So 8 cube, I want to get it 8 cube to the 4th power. So this one I can write as 8 to the 4th power times 3, right? So m cube equals 8 to the 4th power whole cube. So m will be cube root of 8 to the 4th power whole 3. So this 3 we have to bring it down here. So that is 8 to the 4th power to the exponent 3 over 3. So the answer is 8 to the 4th power. So here 8 to the 4th power equals 4096. So the answer is 4096. Okay, here he has given you two equations here, a to the power x divided by a to the power y equals a to the power 1 over 6. So when the bases are same in the division, we subtract the exponents. A to the exponent x minus y equals a to the exponent 1 over 6. So when the bases are same, exponents are equal, x minus y equals 1 over 6. Okay, this is one equation. The other one is a to the exponent y whole to the exponent 4 over 3 equals a to the exponent x. So we multiply these powers, right? That is 4y over 3 equals a to the exponent x. So that is 4y divided by 3 equals x. So multiply both sides by 3, you get 4y equals 3x. Right? Now we use this equation over here. So first we don't have 4y here. Multiply everything by 4. So 4x minus 4y equals 4 divided by 6. So now 4x minus, what is 4y? Is 3x equals, simplify this one, that is 2 over 3. So x equals 2 over 3. So the option is C. Right. Problem number 33 is 9 to the power x times n cube equals 9 to the power. So you are adding the exponents, right? So I can write that one as 9 to the power x times 9 to the exponent 3 over 2. So we can divide by 9 to the power x on both sides. Then this will be crossed out. N cube equals 9. 9 I can write it as 3 square to the exponent 3 over 2, right? So that is n cube equals 3 to the exponents, this 2 and this 2 will be crossed out. The answer is 3. So n cube equals 27. That is n equals 3. The answer is A. Yeah, problem number 34. Cube root of x divided by fifth root of x equals, what I can write this one? This is written in the form of x to the power a over b, that is given to you. Okay, now what I will do here is, this one I can write as what? This 3 we can bring it to the exponent over here, bring it to the exponent over there. Yeah, exponent is 1 here, right? So that is x to the exponent 1 over 3 divided by 1 over 5 equals x to the exponent a over b. So when the bases are same in the division, we subtract the exponents. 1 over 3 minus 1 over 5 equals x to the exponent a over b. So this is x to the exponent, and you have different denominators. Multiply the denominators. 15, cross multiply it, that is 5 times 5 minus 3. So x to the exponent 2 over 15 equals x to the exponent a over b. So this implies that 2 over 15 equals a over b. So a equals 2, b equals 15. So we need b minus a. That is 15 minus 2, which equals 13. So the answer is C. Yeah, with this problem, we finished all problems of benchmark 3 review from 1 through 46. Okay, again I will tell you, in video 1, in the first video, you have the problem from 35 to 46. That is your first video. In second video, you have problems from 1 through 14. In third video, you have problems from 15 to 34. So I explained every problem from benchmark 3 review. So go through all problems and try to get a good grade in your benchmark 3, which will be conducted next week on Monday and Tuesday. Good luck, students. Have a good day.